Good morning. We'll try to see file organization of your records in your file. So there is different ways we can represent. Previously we have seen types of storages in your record, and the organization, the structure, how it is going to be created for to make easy retrieval and easy deletions and insertions. So then there are different kind of techniques which are going to be available. One is heap based representation, and second one is sequential, and next we have a concept called hashing. In the sequential we have two different kind of techniques, p file and file related techniques. So these three different techniques which are used to represent your files and their records in a very structured manner. So we have there is each individual importance for every individual one. So first we'll try to see what heap can do. As we know that heap is used to create a dynamic memory representations in our programming languages, and similar to that, and this heap is also doing some kind of help for us. So in this organization, your records are going to be placed at anywhere in the file system. So there is no problem for to be stored in a specific particular physical location. It is not possible with a heap. So heap is always going with its own choice based representation, and sequential we have an option for that, and whether you can take sequential order or you may take some kind of sorted order, and your data should be represented with some kind of search key because to make your data retrievals easy. So the sequential file system is having a well structured representation. Either it should be going in the sequential order or it is going in a sorted order. So after this, these two representations are used for your single table representations. Then we'll have one more technique, that multi-table clustering file organization. Maybe on a single file, multiple table related information can be stored. So how this will be handled? So there is multi-table cluster file organization system will be available. So here we need to majorly focus on your IO operations. Sometimes it's give minimized representations. Sometimes it takes too much time to read the information. So what are the cases we may have means, for example, if the files are existing in the same physical location, then there is no problem. Your retrieval is going to be easy. For example, if you are maintaining multiple files and multiple files are maintained with same copy of table. For example, employee table is available in file 1, employee table is also available in 2, employee table is also available in 3. So now the retrieval should be happening from 3 different kind of files. So in this case, maybe your IOs are going to be increased. So we have this kind of representations. So in order to make your fast retrieval, we need to go to the concept called indexing, and inside indexing we have a B plus tree file organization. So this is the most important topic in our entire representation of file organization. And next after that we have one more supreme technique, that is hashing. So hashing is also most useful representation to give the particular block to the record, right? So we'll see them one after the other. So next we'll go for your heap file representation. As we said, our records are going to be placed anywhere in your file. So wherever there is a space, there your data will be stored. So there is a beauty thing is records usually written to your file system, but it is not going to be moved anywhere. So previously we have variable length based representation. Once the data is deleted, your records are keep on moving. It is going to produce some complexities. So when to take, for example, your business hours are there, data is keep on writing on your file. So then there is a problem for us. So to overcome this, once your written data will not be alerted, or it was not given to anyone, or it is not moved to any other fellow. So this is how it is going to be works. So wherever your free space is there, it will find the free space, and there you are going to write your data, right? So this is how your heap representation is going to be works. So this free space related details are going to be given in whenever there is a periodical checks should be exist. So every time it is going to keep on check whether what is the kind of content we are going to exist. So there is two different kind of approaches we can see in this diagram. One is your data should be written like this. There are some kind of several blocks are there. So whenever your new delete will be happening, that should be represented in your with the entries. So these entries are having some kind of limitation. It should not consist more than 4 or more than 3, or it is always follow some kind of order representations to maintain some kind of hierarchy in your data representation. So there is a 4 and 7 and what 2 and one more is 6. So there are different kind of data components we have. These are going to be maintained with a map based representation. So this heap is this is how it is going to be represented, but it is not well suited to store your data in the continuous manner, and free movement will not be available at your heap based file organization. So in order to control this, we are going with sequential file based organization. So this named it as whatever your files are going to be stored, that are going to follow some kind of order. Either it should be insertion order, or it should be maintain some kind of ascending or descending kind of order. So whenever you want to store or reorder your files, then you need to follow your search key representation. So based upon one key, we are going to search your elements, and we are going to take place the elements one after the other. For example, if I want to insert a new entry, so then I need to check this all the records related content, then I need to insert my data. For example, if any ordered mechanism we have, so new entry is coming, so then I need to check this keys, and wherever it is takes place, there I am going to represent some kind of data. So this file system, sequential file system, is going to be store your data in the two different techniques. One is P file, and second one is sorted files. So in this P file, your data is going to be stored in the insertion order. There is no different kind of approach we have. So whenever your file is there, there is a one end beginning and another end is ending. So whenever a new entry is coming, that is going to be takes place after this ending point. So there is no ordering, there is no guarantee in your ordering, and as well as it always follows only a concept called insert order. So this is how your data is going to be managed. But there are some kind of problems we are having with this file and file method. One is your reading is bit complicated. Why? Because for example, you are checking for R3. Just assume that R3 file is exist here. Here your R3 is existing, and your search should be start from this. After verifying all the files, then you need to go through with R3. But actually R3 has to be takes place at index 3. But due to this insertion order, your 3 file will be here. So most of the cases, your divide and conquer approaches related or optimized based representation will not suited to read the data or to write the data into that particular block. So it is always takes some kind of highest time complexity to find the data which exists in your file. So in order to work like this, there is some kind of techniques sorted order. Initially the data is going to be inserted into your file at the end of your file, but after some time it is going to take a recovery representation, and your data is going to be sorted based upon your search key. So based upon your search key, the data is going to be rearranged in your file system. So it may consider as complex, or economically it is giving some kind of burden every time you are changing your records. So this will be happen, but your retrieval may takes faster, and if your insertions got improved, or if your updations or deletions or any kind of operations in your file system, maybe it was easy, because your file system may divide into two halves. One half based upon your mid value, like your binary search, your elements will be identified. So this is the most effective representation in your improvement of your database retrievals. So this is how your file system organization will be happening. So there is a very simple, and we have two different techniques in your files, sequential file system. One after the other, your files are going to be stored by using a search key. So whenever if you are going with the insertion order, you can insert your data, or if you are going with sorted order, you can observe this. So there is an entry will be happen, this will be takes place, and after some time it is going to be swapped with your places wherever it is going to be fit. So 32,022 will be fit in the particular record here. So the insertion will be happen like this. Your insertions will be handled. So multi-table clustering is looks very difficult for our general databases. There is no DBMS, no SQL DBMS. We have several things nowadays. So this is how your multi-table clustering will be store your data. So we will categorize your data based upon your different kind of keys. For example, we have a computer science, so all your computer science fellows will be stored at single place. If your physics place, so some physics fellows will be stored in this particular notation. So like this, your data will be stored based upon your priority. Either you may go with salary, or you may go with ID, or you may go with department name. So based upon your option, your data will be set. So this is how multi-table representations are going to be happen. So now there is two more memory components in our regular perspective. And before entering into this and in your sequence and multi-table clusterings, so to make this retrievals as a bit faster, so then we need to go with a concept called indexing and hashing. So we'll see them in the next video. And before going to your indexing and your other things, first try to understand that what are the importance of your memory components. Data dictionary, everyone knows, this is about metadata, and it is always maintain some information about your database tables and relationships, what kind of data you are using and what are the constraints we have, what is the account information, and to improve the performance we need to identify statistical representations in your data dictionary, in what way you can retrieve the better information to the user. And it is also maintain your file organization. It means the path details also it is going to be stored in your data dictionary. So without data dictionary you're unable to identify your tables, physical files which are existing for your database. So it consists all kind of metadata in a single place. So after that there is a beautiful concept for your buffer caching. So this is having highest priority as per our representation. The data before a client is going to do anything without touching your buffer, you could not able to read or write your operations on your file system. So you could not do anything. For example, a client wants to access the information. That information can be retrieved from your disk to buffer, and buffer is going to maintain some kind of blocks like this, and it consists this kind of blocks information, and the data should be written to this kind of blocks before committing your data. Once the user is committed, the data will be written to your disk file. So in this process, how this buffer is going to manage the data. For example, all the data is filled with your buffer. Then what we are going to do? So to handle this, we have buffer, and buffer is also having a buffer manager. So he is going to allocate which blocks I need to remove, which blocks I need to capture. There is a recovery, there is a policy we have to handle these buffers. So before entering into this, we'll try to see what are the right. So there is buffer manager. Buffer manager is having some kind of duty. If the block is not available in the buffer, for example, if the block is available, then so we can manage and we can handle the data whatever is existing in the particular address. If the block is not there in the buffer, so then what we need to do, we need to produce some kind of lock on your block, whatever the data you want to retrieve from the component, and after retrieving that we need to allocate some kind of space to the blocks, to the content whatever we are retrieving from your physical file system. So you can replace them. For example, already your database is filled, you can replace some of the blocks by following some kind of policy in terms of named as LRU or MRU. We'll see them, and if you are having some kind of empty block, you can write them. Alright, if it is already available in your buffer classing, no need to rewrite them in your buffer. So this is how your data is going to be managed. And after this, we have some kind of buffer. The buffer blocks will be treated as pinned buffer or unpinned buffer. Unpinned means if the data is already written, and if you are saying commit, it means the data should be written to your database permanently. So in terms, those blocks will be called as unpinned buffers. If you are going to say them as a pinned buffers, then the new insertions will be happen before writing them to your physical file. So whatever the data is existing in your buffer, that should be represented as pin buffer. And as well as you need to follow this kind of locking mechanisms. We have seen them in your 4th unit. So whenever you are acquiring any kind of whenever you are required any kind of data, you need to acquire some kind of locks. So this should be handled like this. And after that, we have a mechanism called LRU, recently used and most recently used. Least recently used and most recently used. Least recently used items will be removed first, and most recently items should be saved, and it will be wait for some kind of time. So this is how your buffer replacement policies are going to be works. That's all about your chapter 1.